Okay, so AP doesn't have a whole lot of questions on this, so I kind of made up this question. Hopefully it works out. You got a hollow tube, a length 1 meter, open at both ends as shown. You got a tuning fork of 175 hertz. One end, and it causes the air to vibrate its first harmonic. Now, what does the first harmonic look like for an open tube? At the open ends, what do you have to have? An antinode at open ends. So you've got an antinode at this end and an antinode at this end. First harmonic will have just one note. So you end up with a wave that looks like this for your first harmonic, which should be centered on the middle there. Sorry, that's terrible. Oops. We'll just drag that around for you too. A node should be at the middle of that pattern that looks like this. That's the first harmonic of an open tube. Open ends have to have antinodes. Closed ends have to have nodes. So a lot of you drew the harmonic for this. Or for a fixed string, nodes at both ends, it would look like that. But for an open tube, you must have an antinode at open ends. So that's what the first harmonic looks like. Now what's the wavelength of the sound? Well, we have a hollow tube of a wavelength 1 meter. How much of a wave does that first harmonic represent? We have half of a wavelength in that tube L. So the wavelength of the sound, I have half of a wavelength in that 1 meter tube. So the wavelength is 2 meters. Speed of sound inside the tube. E equals F lambda. Frequency given to us is 175 hertz. Wavelength, as we discovered, is 2 meters. Your velocity of 350 meters per second. I skipped the question on temperature. Temperature is 331.5 meters per second plus 0.6 T. That's the velocity of sound. We got the velocity of sound to be 350. G for T? 32 degrees ish. Is that hot or cold? It's hot. It's what? You got what? Oh, I think we all know how to use a calculator at this point, right? 30.833. 32. So liars. 31. Not sure how you got 32. Anyway. 331 and a half. That's right. 31. Yeah, that's warm. That's hot. Warm, hot, depending on how you judge your own temperatures. That's the next higher frequency, which would generate a resonant pattern. Now, you have to look at what the next resonant pattern would be. The first one is this. What would the next one look like? We have 2 nodes and antinodes at the ends. So we have a full wave. So we have a 1 meter wavelength there. At 350 meters per second, the next frequency which would generate that is 350 hertz. So 350 hertz generates the next resonant pattern. And if you desired, you could go up another step to 525 hertz and get another resonant frequency.